Okay, electric field Ex Ey z equal to A into xyz represent the electric field in a free space. Then A can be in the form of 4 options are given, 3 into 3 matrix. So free space represent charge density 0. Using this, what we can do? So writing the E equal to A into xyz as a equation form, Ex equal to Axx into x, Axy into y plus Axxz into z. Similarly, for 3 components of electric field, we are writing the equation. So since for free space, charge density is 0, del dot E equal to 0. Divergence of E equal to 0. Dou Ex by dou x plus dou Ey by dou y plus dou Ez by dou z equal to 0. So substituting the value for Ex. So what we have written in the previous equation, Ex, differentiating with respect to x, you will be getting Axx. Similarly, dou Ey by dou y, you will be getting Ayy. So we will be getting Axx plus Ayy plus Azz equal to 0. So these elements are the diagonal elements. Therefore, the trace of the matrix is 0. Trace means sum of the diagonal elements. Similarly, for free space, del cross E equal to 0. So finding the curl of the E vector. This is the curl of the E vector. Writing the ith component, dou by dou y into Ez, dou by dou z into Ey. Substituting the value for Ez and Ey and differentiating the Ez plus by y, you will be getting Azy equal to Ayz. Similarly, jth component, you will be getting Az equal to Azx. Similarly, Axy equal to Yx. So these are the off diagonal elements. So they should be equal. That is symmetric matrix. A should be 2 conditions we have verified. One is trace is 0 and symmetric matrix. So comparing these 4 options. So here the option D is correct. Trace is 0 and they are symmetric matrix.